All right, 5.4, sum and difference formulas. Okay, if you're watching this video, unfortunately, you did not get to see the proof. The proof will be posted on the Learning Hub if you're interested. Okay? All right, I'm going to introduce you to 6 formulas that you're going to have to memorize. So, unfortunately, sorry, here's more things you need to memorize for my class. Okay? First of all, you already know one since we talked about it. So, for example, if you have sine of x plus y, who remembers it? Okay, that's the one that we proved in class. So sine of x plus y equals to sine x times cosine y plus cosine x sine y. Okay, that's the sum formula for sine. Well, there's also going to be a difference formula for sine, which is going to look like this. Shocker. Now they're being subtracted. Well, guess what? The formula is exactly the same, except that you have a minus sine of x cosine of y minus cosine of x sine of y. So in reality, yes, it is 2 brand new formulas for you, but if you memorize one and just remember when it's plus and when it's minus, you're good to go. Yes, sir? Stretching? Okay. Ready? That's for sine, so guess what? There's more trig functions, right? Oh. What about cosine? Alright, so for cosine, here's the formula. Cosine of x times cosine of y. Notice how I'm adding, okay? This is where it gets tricky. Instead of adding, you're going to do minus. Sine x, sine y. Cosine of x minus y. Guess what? Luckily for you, looks exactly the same, but what switches?
The minus sign and the plus sign.
So cosine x, cosine y, plus sine x, sine y. Okay? We've only got 2 out of the 6 trig functions. Ooh. Luckily for you, we will only be using sine, cosine, and tangent. We will not talk about secant, cosecant, and cotangent. No, like this course will not cover those. Okay? Alright, the next one is tangent. Tangent of x plus y. By the way, if you're watching the video, I want to make sure that you understand that x and y are angles. Okay? We're talking about angles, right? Okay. Tangent of x plus y. Alright, this one looks a little different, so bear with me. This one looks the following. Tangent of x plus tangent of y divided by 1 minus tangent x tangent y. You're welcome. You're welcome. I love giving the knowledge. Alright, last one that we'll use in this class, tangent of x minus y. If you've noticed a pattern, they just kind of seem to switch signs. Agree? So the only thing that's going to happen here is that it's going to become tangent x minus tangent y over, can you guess what's going to happen in the denominator? 1 plus tangent x tangent y.
Do we have a formula chart?
No. Guys, settle down. Yes, sir.
For the proofs, is it the same, like...
Image? Yes.
Okay.
Alright, listen up. There is 6 formulas in here, but in reality, if you think about it, it's 3 that the signs are switching. You have to memorize them. I'm sorry. Welcome to Pre-AP Pre-Cal. Okay? You can't drop my class anymore. Let's continue. we're now going to apply these formulas, and we'll start out with an example. Example number 1. I want you to, first of all, here's the instructions for all of this. Find the exact value. What does that mean?
Like, don't use decimals.
No decimals. If there's roots, you gotta keep the roots. Like, it's gotta be exact. Okay? Here's the question. What is the cosine of 75 degrees? All right. In order for us to use these formulas, we have to find two angles that either add up or subtract to be 75 that are on the unit circle. So how can I rewrite this?
Cosine 45 degrees.
Cosine of 45 degrees plus 30 degrees, right? I need to find out what that's equal to.
Let's see what the cosine.
Now, go back to your formulas. If you are adding, we're going to use this formula right here. It says, take the cosine of the first angle and multiply by the cosine of the second angle, right? All right, for our purposes, we have the cosine of 45 times the cosine of 30. And then what do we do according to the formula?
Add.
Minus
Oh, sorry.
the sine of 45 times the sine of 30 degrees. Did I lose anyone with what I did? Are we good? Guess, yes ma'am. It doesn't matter here because you're multiplying. But the order of where the cosines are and the sines do matter, and that's where you're going to have to learn the actual formula. Okay? Now, here's my question to you, and hopefully by now, we're still struggling with our unit circle. It's not going away. Your unit circle. What's the cosine of 45 degrees? Root 2 over sine of 30 degrees. Root 3 over 2 minus, what's the sine of 45? Square root of 2 over 2. And what is the sine of 30 degrees? 1/2. You guys with me? And from here, it's just algebra. Square root of 2 times square root of 3 is square root of 6 over 4 minus square root of 2 over 4. We have two fractions that are subtracted with common denominators, so I can combine it to make it one fraction, agreed? Square root of 6 minus square root of 2 over 4. That is an exact answer. Don't go any further than that. You cannot subtract square root of 6 minus square root of 2 and say that that's square root of 4. It's not possible. Good. Okay? Do you guys see how we're using the formulas? Alright, before we move on to any other problems, do I have a question on this problem? This will take practice just like any other formula we've been using in this class. Okay? Now, these formulas are both applicable to not only degrees, but radians. Now, notice I started with degrees because it's a lot easier for you to come up with two angles to add or subtract that is going to give you a nice whole number, right? When it's radians, it becomes a little bit more challenging. So we're going to do one in radians. Are you ready?
My body is ready.
Okay. What is the sine of pi over 12? Okay. Hold on. Pause for a second. You're on the right track. Hold on. Alright, here's my suggestion to you. Obviously, you can tell that pi over 12 is not on the unit circle, right? But you need to look for two angles on the unit circle that would either add up or subtract to it. Here is my suggestion to you. You can take your unit circle and start with 0. So you have 0, you have pi over 6, you have pi over 4, and then you have pi over 3. How about you change the denominators on all of those to 12 to help you out? What would pi over 3 become into terms of something over 12? 4 pi over 12. What does pi over 4 become? What is pi over 6? 2 pi over 12. Look at those angles. Is there any of those angles that you can either add up or subtract that would give you pi over 12?
Yeah, power 4.
If you take this minus that, you're going to get pi over. So then we can say that this is the same thing as saying sine of, yes sir? Yes. Here's what we need to do. You guys realize that I need to do this minus that, right? Are we okay with that? But this is not how it's written on the unit circle, right? But you know that that's the same as pi over 3, right? So could I say pi over 3 minus pi over 4? Okay? We only wrote this to help me figure out what they would be. But you got to make sure you go back to the angles that are on the unit circle. Okay? Now, it's the formula of difference for sine. And just a refresher, it says that it is sine of x cosine of y minus cosine x here. If we're doing sine of pi over 3 minus pi over 4, it's going to be equal to what? Sine of pi over 3 times cosine of pi over 4 minus cosine of pi over 3 times the sine of pi over 4. Yes, sir. What's that? What do you mean? What's the sine of pi over 3? You're thinking solving equations. Okay? Alright. What is the sine of pi over 3, guys? Root 3 over 2. What's the cosine of pi over 4? What is the cosine of pi over 3? And the sine of pi over 4 is? Okay. Root 3 times root 2 is root 6 over 4 minus 4. So this is root 6 minus root 2 over 4.
So could you have gotten that by knowing that it's the same triangle?
Not really. No, it's not. Okay? Alright. Guys, stay with me. We've just started. We haven't really gotten to any good problem. Okay? Stay with me. Alright. I'm going to be honest. The challenging part of this problem was not the formula, was what?
Just figuring out which angle.
Coming up with the angles. Okay? Worst case scenario. I'm going to be honest with you. Worst case scenario. You're stuck in a problem like this. You should remember how to turn radians into degrees to help you out. Agreed? Okay. That's worst case scenario. Right? Questions about this problem before we move on? Okay. What if I give you something like this? Find the exact value of the following. You ready? Sine of 42 degrees times cosine of 12 degrees minus cosine of 42 degrees times sine of 12 degrees. Pause for just a second and look at this. What did I actually do this time?
Oh, it's the formula of the sine.
I gave you the formula. You just need to work backwards. This is sine at the beginning, so that should tell you, if you go back to your formulas, it's either this one or that one, right? Which one is it, the addition or the subtraction one? It's the subtraction one. So in reality, what this is trying to tell you, it is saying that this is sine of what minus what? 42 minus 12. Agreed? Well, what's 42 minus 12? Sine of 30. And that's on the unit circle. What is the sine of 30? So, To summarize, sometimes I can actually give you the end result and you need to recognize how to go backwards, or I can give you an angle and you need to be able to split it into two angles. Okay? You guys with me? Good. Then you figure this one out. Try this one on your own. Cosine of 5 pi over 36 times cosine of pi over 9 minus sine of 5 pi over 36 times sine of pi over 9. I need you to try to figure that one out on your own. Go for it. Alright, if you are watching the video, please pause the video at this moment, check out my work and compare it to what you have. Questions, class, before we keep going and practicing more of these problems. We're good? Okay. It's time to use that tangent formula. Why not? Yes, sir. Then that means, I'm going to be honest, I won't give you something that is not on the unit circle, so that means you did some arithmetic wrong, so go back and check your work. Okay? Alright, ready? You should be able to recognize this one on your own, because you have the formulas next to you. So what if I have tangent of 30 degrees minus the tangent of 60 degrees all over 1 plus tangent of 30 degrees times tangent of 60 degrees. Which one is that? Is that the sum or the difference? This is the difference, so this becomes tangent of what? 30 minus 60?
Yeah.
Very good. Which is tangent of negative 30 degrees. And you're like, oh, are you kidding me?
It's negative root 3.
Well, where is negative 30 degrees located? What quadrant?
4.
Quadrant 4. All students going to be positive or negative? So your answer is going to be negative. Well, what's the tangent of 30 degrees? Root 3 over 3. Please make sure that if you still have not memorized your tangents, do so. I don't want you to be lost on this because you're still trying to figure out what tangent and what cosine and what sine is. Okay? Alright. We're almost done with notes, actually. We have a few more problems, and then we'll move on. You can actually also have proofs.
No, come on, man.
Okay, I'm mildly confused.
I want you to prove the following. I want you to prove that cosine of 90 degrees minus x is equal to sine of x. In other words, this is very similar to what you did on 5.2. You're only working on one side. You're only working on the left-hand side. Agreed? Alright. Ignore this and pretend this looks like the problems we've been doing. This is a difference of cosines. So the formula says to do cosine of the first angle times cosine of the second angle. You have to think opposite, so plus sine of the first angle times sine of the second angle, and that should give us sine x. Agreed? That's where we're going. Well, how well do you remember your unit circle? What's the cosine of 90 degrees? 0 times cosine x is just going to start cosine x. Plus, what's sine of 90? 1 times sine of x, right? 0 times anything is 1 times sine is sine of x equal to sine of x. Bingo. It's a proof. That's fine. Yes, you can put this. Okay? Alright. In other words, you can do what we did on 5.2 now using these formulas. Okay? Alright. I want you to try one on your own. I need you to prove or verify, same thing, prove or verify, that sine of x minus pi over 2 is equal to negative cosine of x. So if you're watching this video, go ahead and pause it and then just press play when you're ready to see the answer. Alright, if you're watching the video, go ahead and check your answer. It only really took us 2 steps to get to the final answer on this. Okay? Alright, questions before we move on to our final topic of the day. Are we good? Well, we don't have to be completely there. Obviously, this is the first time you're seeing it, but do you at least understand the problems that I've done so far? Okay. Which takes us to the last type of problem that we're going to do in this section, which is solving equations. Solving equations. I want you to solve the following equation, and I'll solve it with you. Sine of x plus pi over 4 plus sine of x minus pi over 4 equals to negative 1 on the interval from 0 to 2 pi, where 0 is inclusive and 2 pi is non-inclusive. Okay. You've obviously solved equations before, so this is not something completely new to you, hopefully. But there's some identities that you're going to have to use that you have not used previously. What I would begin with is using the identities that you learned today. First, we need to use this identity to help us out, what this would be expand to be. So what does this sine x plus pi over 4 expand to be? Sine x cosine pi over 4 plus cosine x sine pi over 4. I suggest that you use parentheses here to split things up, okay? Plus, well, now we need to expand this sine x minus pi over 4. Sine x cosine pi over 4 minus cosine x sine pi over 4 equals negative 1. You guys with me? All I did was use the formulas that we've learned today. Always use parentheses, please. Always. Like, even in this problem, they're going to be pointless, but always use them, especially when you do subtraction. Okay? Let's start simplifying things out. Sine x times cosine pi over 4. Well, what is cosine of pi over 4? So are you guys okay with me saying that this is root 2 sine x? Plus, what's sine of pi over 4? So are you guys okay with me saying that this is plus root 2 over 2 cosine x? Right? I'm going to keep the parentheses and I'm going to say plus. Well, what is the cosine of pi over 4? So root 2 over 2 sine x minus root 2 over 2 cosine to negative 1. Agreed? Hopefully, you will notice that, thankfully, some of these things are going to cancel out. You have a sine, you have root 2 over 2 sine x plus root 2 over 2 sine x. What does that mean? You have two of them, right? But here's what's going to happen. You have one of this, and then you're subtracting one of them. You guys agree? Okay, so you guys okay with me saying that I have 2 times root 2 over 2 sine x equals to negative 1. Do we understand where this 2 is coming from?
No.
You have 1, you have 2.
Okay.
Yes? Okay. I didn't want to skip a step. I wanted to show that. But what's going to really happen with those 2's, guys? You guys see how this 2 and this 2 are going to cancel each other out, leaving you with square root of 2 sine x equals to negative 1. And this has become a problem just like we've been doing them in 5.3. I need to isolate sine, so what are you going to do?
Divide root 2.
Divide by root 2, divide by root 2. Therefore, this becomes sine of x equals to negative 1 over root 2, which you should know by now that that's the same thing as saying negative root 2 over 2. Agreed? Where on the unit circle from 0 to 2 pi is x root 2 over, negative root 2 over 2?
5 pi over 4, 7 pi over 4.
7 pi.
7 pi.
5 pi over 4, comma 7 pi over 4.
That's it.
I knew 7 pi.
Okay. Here's what's going to happen. So it's 3:47 we got here, so we have about 25 minutes left in class. Okay, I have last problem. You're trying on your own, and then I'm going to give you your test. Okay? You've already taken your test. You're going over your test. Okay. Ready? All right, I need you to try this one on your own. If you get stuck, I need you to call me over so I can help you. Sine of 2x cosine x plus cosine 2x sine x equals to the root 3 over 2. From 0 to 2 pi, 0 inclusive, 2 pi non-inclusive. Go for it. Alright, if you're watching the video, please look at the work, pause it, and try to find out if you made a mistake. Other than that, that is all I got for you guys today. Homework is on the calendar. It's off the textbook. Guys, you definitely need to practice this. I'm going to be honest. Suggestions for those of you watching the video and my class as well. If you're having trouble memorizing some of this stuff, I suggest that you do flashcards. And like on the weekends, on like 5 minutes or something, play with your flashcards until you memorize these things. Okay? That's all I got for you today.